Can the AI reason, or is it just responding?
OpenAI was able to source so much data to be able to train their models. I mean, OpenAI for the longest time has been under the scanner, for using data without permissions.
Whoever are the producers of data, and I think they need to have certain benefits. It's easy to say if we have a magic wand, we would fix all of these things with AI, but I think it's just a natural progression kind of with technology. I encourage leaders to actually test AI demos with questions that require reasoning or combining facts, and it's going to be a long time before we actually get to something that can completely replace us.
Welcome to Discover Dialogues podcast, powered by TechDogs. The world of business and technology is evolving at breakneck speed. AI breakthroughs, digital transformation, and game-changing innovations are reshaping industries every day. On this show, we dive into the trends, ideas, and strategies driving the future. We're sitting down with industry leaders, innovators, and disruptors to bring you fresh insights, bold perspectives, and real conversations that matter. So plug in, tune in, and let's discover what's next.
Today on the show, we have Dominik Tomicevic, the founder and CEO of Memgraph, a real-time graph database company that's redefining how AI systems process and reason with data. With a background in software engineering and a passion for solving deep structural problems in AI, he's also a vocal advocate for open source development, AI ethics, and using structured data to create AI that doesn't just mimic understanding, but actually reasons. Dominik isn't just building faster systems. He's building smarter ones. Let's dive in. Thank you, Dominik, for joining us today. Welcome to the show. We are thrilled to have you on the Discover Dialogues podcast. Dominik, your background is in computer science, from the University of Saarbrück, and I'd love to understand, how did your academic journey shape your interest in graph theory and complex databases?
Thank you for having me on the podcast. Excited to be here. I think from the early days, even before the university, I used to do a lot of something that's called competitive programming. I was never top tier, of course, but it kind of got my interest into the world of algorithms and kind of led me to this journey with kind of the rise of big data and data science kind of back in the early 2010s. And kind of through that journey, I think I've discovered a lot of the data problems being graph problems. And that's kind of how the entire journey was shaped kind of from the beginning in the world of graphs, just embedded into all sorts of different problems.
Right. And was there any specific, problem or a moment that kind of catalyzed your journey?
There was a few, I think. One I think particularly interesting is kind of in the domain of natural language processing, kind of getting, it was the early days, right? Now Gen AI is doing lots of interesting things there, but in the early days, a lot of things was around kind of structuring the data. How can we take natural text and then extract useful information from the text and create some sort of a structure. And when we're talking about structuring the entire internet, basically, and whatever domain or topic, I used to work in a couple of domains specifically. It's actually a pretty rich model. Right. And it was very difficult kind of to fit that model into a traditional medium because all the time some different new types of entities, new types of relationships kind of would be created. And of course there was the obvious kind of do you go with kind of the NoSQL realm and be able to kind of have free schema, but then I lose a lot of the information about the relationships and it's just difficult to kind of connect things together or kind of go the SQL way. And then back then we had kind of the old generation of SQL that was very inflexible. Lots of things didn't work. And that's how I stumbled upon graph databases. Right. In particular Neo4j. And it kind of opened my eyes to a kind of a new way of thinking. So, and it's something that I've been talking to my co-founder. We really got pulled into those graph databases and it all came from this kind of hitting the wall that we had with the tools that were available. I think kind of moving forward from graph databases as a concept. So around 2015, working on a project where we had to digest lots of kind of interconnected data streaming. So thousands of events per second and also answer complex relationship queries in milliseconds. seconds. So the graph database is out there. We tried back in the day. Who knows? Maybe today situation would be different. It is certainly because of Memgraph, but more into that later. But of course, none of them could handle those kind of real-time updates with low latency. And then it's like weeks of trying hacks and workarounds, and finally having this light bulb moment. It could be because maybe my co-founder and I had a beer too many while talking about this, but we were thinking, like, what if we built our own engine that's kind of specifically tailored to kind of real-time graphs? And that's how kind of the idea for Memgraph was born. We didn't know if we would make it a company yet, but yeah, from the beginning, we were thinking about the use cases that we were solving. We engineered it in memory from day one, so we could ingest kind of a constant stream of updates and still be able to query fast, essentially. And the specific pain point is kind of not being able to get immediate insights from fast changing data. So this is what absolutely catalyzed my journey and shaped my startup career, and also working with lots of interesting companies solving interesting problems.
Nice. So it's been, I think, almost more than, I would say, a decade or maybe two now, in the sense I dabbled in a little bit of coding myself. But since then, obviously, things have changed quite a bit and I've moved into marketing. For our listeners, new to graphs specifically, the way I look at it, relational databases are like libraries and graph data are like Wikipedia, where, everything's kind of interconnected. But how would you explain to our audiences, what graph databases are? Why are they considered so powerful?
Yeah, I think a lot of people have, there's the misconception where, oh, graph is that a chart? It's an unfortunate mathematical term, because we had mathematicians kind of way back in the times have defined graphs kind of as a structure that has nodes and then relationships kind of between those nodes. And it's a very abstract concept that later has been adopted here kind of in the data realm, where imagine if your node could hold information the same way as like a row in a spreadsheet would be, or in a relational database, or just like a JSON document. So you have a document, but then have the collection of these documents, and then how do you kind of link them together? And it's in simple terms, I think what you write a lot of the times on the whiteboard. So if you write, oh, this person is connected to the other person, or this person works in this company. So a lot of these concepts we actually use naturally, but we then make it more tailored for the machines to store. And that's how we kind of started with the whole relational algebra and lots of other approaches. So we actually tailor our own thinking into what machines can store the best. While in kind of a graph sense, it's all about giving you a way to store the data naturally as you're kind of thinking about the data. And this enables you to have hundreds of thousands of different types of nodes and relationships, and not being kind of lost, kind of what can you connect with what, essentially. Airbnb is one of the examples. They actually built kind of an index in a graph to actually show people, hey, you can join this data, or this data relates to this data, because they're kind of tables in Hive. They had back in the day, it's hundreds of thousands of different tables. So as the data gets more complex, as the data evolves, the benefits of graphs, just in terms of the pure modeling perspective, are more obvious. But also, a lot of the data is very natural to being graph data. So any type of physical network, or things like social networks, who is connected to who as kind of friends on social platforms like Facebook, for example, or just if you want to go into physical infrastructure, so gas pipeline, fiber optic lines, energy distribution grid, for example. So all of these things are natural graphs, and there's hundreds of years of theory and algorithms from mathematics that we can actually take advantage of, that can detect certain patterns in those types of networks. And they can tell us some things about how things are behaving in the network. If you have like water distribution network, you can detect leakage from, for example, or if you model it in a more kind of a modern sense, where you have financial services data and you have people taking out kind of banking loans and doing car transactions and other things. So you can model behavior, and you can model how they behave with other people kind of from the network. You can use it for certain kind of tailored recommendations, but also to detect kind of fraud and bad actors and collusion and how people kind of work together, because it's easy to cheat on rules. So if you have like strict rules, it's like don't do transactions over $10,000. Got it. It's like 9,999. So it's going to be just below the $10,000 line. But you can never misrepresent the network behavior. So how you behave in the network is always going to kind of give you up. And that's why graphs have been popular kind of for that use case as well. Supply chain is also a very interesting use case where you essentially map your kind of bill of materials, and then to make a car, I have all these parts, and then I have a wheel, and then wheel breaks down into these parts, and these parts break down into these bolts, and I get these bolts from this supplier, I get these parts from another supplier, and you can essentially track how when will you have all of your stock, what is the stock that you have currently. You can predict kind of based on the demand that you have, you can predict kind of how many cars can I deliver. So lots of very natural problems mapped to graphs. And I would say, I'm biased a little bit, but I would say pretty important problems to solve.
Got it. And talking about, AI, how do, graph databases and AI come together, and what are some of the benefits of using graph databases while implementing AI or in AI solutions?
Yeah, so this is kind of a very new topic, and it's sort of very exciting. And I think the best thing kind of to think about it unlocks the capabilities that we've had in graphs for a long time. So now people can interface with the graphs more naturally through Gen AI LLMs, but also we can make kind of tailored context recommendations and really help support kind of the reasoning and all the complex tasks that we're actually asking of Gen AI systems today. So the big advantage, of course, as I mentioned just from the graph perspective, is that these systems need to think in relationships and kind of not just statistics. And currently, traditional AI models just try to kind of absorb the entire world implicitly in their kind of weights, but graph kind of explicitly maps out the facts. So it's kind of a knowledge web that we can walk. So whenever you say you ask a complex question, a graph can trace the path through all the relevant facts. It's doing kind of reasoning by following connections that we know are true if we have a very structured kind of knowledge base, rather than just predicting kind of what the connections are because we saw certain words together, for example. And it makes a huge difference. So if you ask a question about how a certain component failure in a network could impact, say, a service downstream, a graph can pinpoint the chain of link components, give you an answer based on real dependencies that stem from the graph that is actually understood in ground truth by the fact. So a standalone AI might give you a generic guess or even a wrong answer, especially if you're doing things like counting. So let's say you have a map of all of your AWS infrastructure, which a lot of the cybersecurity companies today do in order to map out kind of what are the vulnerabilities, where the bad actors, kind of what service can communicate with which other services on my AWS network in my account, and how to propagate kind of those vulnerabilities downstream. So if you have that and you ask it more of a simple question, how many of my servers have like X, Y, and Z? Because you're relying in putting the entire data in the context, and an LLM kind of implicitly kind of numbering things in the context. They're getting better all the time, and as they get better, it's certainly the improvements that we're going to see kind of across the board, and even kind of together with using graphs, it's going to be great. But those are still things where you can hallucinate very easily. But if you can teach the graph instead to run deterministic queries and have access, and I think the model context protocol is very kind of useful in that. And we have an integration as well with that, for example, to kind of get to the facts that you have in the system. So it's gonna get even better, because you're gonna teach it how to get the right information in the right way to recognize kind of its own weaknesses. So I think we're very excited about that future.
Nice. So personally, I'm a huge proponent of AI. And what I find fascinating, Dominik, is that I think in the last 6 months or so, AIs have been AI agents, or I wouldn't say AI agents, but AI chatbots have been able to hold a conversation. They've been able to maybe write poetry or maybe even mimic things. But at the end of the day, they do give off that, vibe, and I'm going to call it vibe because it almost feels like they don't understand anything. And that leads me to something that you've said before once, or I've read at least, is that AI should understand, just not predict. But you've also gone ahead and compared AI systems to parrots. So how do you distinguish between sounding smart and actual reasoning, and AI systems for that matter?
Yeah, I think that that's a very good question, and I think the earlier you go, kind of in the journey. So if you go the era of GPT 3.0,
Yeah.
and earlier, you will immediately kind of see the comparison why they really sound like parrots, because you will catch them almost immediately saying things that don't make sense. But they're getting more sophisticated, and it's a lot easier to kind of fool us into thinking that the behavior is very good. And sometimes you really need a domain expert to distinguish between a hallucination or not a hallucination, of course. And if you're trying to use it for something that where you don't have the expertise in that area, and you're trying to learn, it can be quite disastrous kind of in that scenario, because you're relying on something that there might be a hallucination. But I think a lot of the people who have kind of tried, who are domain experts in a certain area, and then you try it, and it's very easy to spot kind of those differences. So yes, that's kind of how I compare them to parrots. And I swear, I mean no offense to parrots. I actually had a few as a kid, so it's a good thing. But kind of the idea that the models can repeat and remix information very convincingly. So that's kind of the main idea. So if a parrot kind of hears the pilot in a plane and can repeat all the like cockpit commands, it might say like set throttle to 80%, deploy flaps, and even if it says it in the right sequence and tone, it sounds like, if you're at air traffic control, it's like, you're listening, and it's like, it sounds like what this guy is talking about, right? But if you ask the parrot to actually land the plane, it probably couldn't. So it just doesn't understand the whole things, and the kind of all of these relationships and all of these context things. So it's similar with kind of the GPT architecture. So we're kind of hitting the limits because we don't have as much data, and still the transformer architecture is very transformational for AI, but it's still just based on statistically predicting what comes next based on what was before. And it's very easy to miss the things that it has never seen. For example, if there's something, if you're asking something that's on the cutting edge to help you with maybe, and I've tried quite a bit for maybe product marketing for certain use cases where I've seen like very new use cases for graph. It's like, oh, can you just help me kind of think through this more? And it kind of repeats the things that were before, not in the direction where I'm trying to kind of go. But yeah, certainly for so many kind of orders of magnitude ahead, I think it's an exciting time, and I don't think this is a bad thing. So I think there's lots of use cases where we can Gen AI today very effectively, and it really kind of can improve workflows, and I mean ultimately improve lives.
Yeah. Sometimes I think of AI having surface level intelligence, and when it really comes to contextual reasoning, or the way we would reason, something that's a decision that we're about to make, it just doesn't get it right. And to that, it's one of the questions that I've always had, and I'm trying to answer for myself, is why is it that reasoning is so hard to teach to machines?
It is very hard. It is very hard because we evolve as humans in a much different way. The way we kind of can synthesize facts and capture facts and evolve kind of in real time, because we have these I think different centers, because sometimes you remember some things, and then from what you remember, and then you learn frameworks and ways of thinking about some things over the course of your life, and then you have those light bulb moments where it's like, I can apply this to that. And the way kind of we're good at synthesizing the data, it's a much different process than just predicting what I've seen before. And it's unless we have been training on the exact ways of thinking or injecting some deterministic logic where we know it needs to think differently, it's a lot of issues when trying to kind of teach it to reason, because it's essentially taught to just repeat the information that it hears. So I think for now, at some point, hopefully we'll have something that will be a more kind of general solution to the problem. Right now, we can achieve similar capabilities, at least for the domains where you know what are those frameworks, what is the domain language, what are the types of steps for certain jobs that you've encountered before, and how to solve those problems. So that's something that you can embed in a graph. So it can be a very complex decision tree. It can be a full graph that has cycles if you need to do some kind of repeating things. So it's a very nice way to actually encode that information and have an LLM at every step of the way kind of follow those things, and have deterministic ways of that you can actually combine even kind of LLM outputs and make it more probabilistic about which path to take if you wanted to have maybe some different ways of going depending on what you're asking. But a lot of the times we have those frameworks known in advance. We know what are the series of steps, what are the possible paths to take, and that's where we can actually employ AI to kind of guide the user, or if it's given a task, or if the user is prompting and it figures out, oh, it's this task, so I need to run a predictive model, for example. So if we're trying to ask it, oh, what's going to happen with my sales data or sales performance, what is the projected value for the next quarter and the quarter after that, it's just a guess. It's a hallucination if it doesn't recognize, okay, there's these predictive models my company has based on the past sales performance that I can run, and they're deterministic. They're going to tell me kind of what is the expected. And where AI is very nice in those is that it can run those predictive analytics and get the raw data or the raw results out. Humans are very bad at looking at numbers. But exactly. And if there's just a bunch of different numbers, it's hard to kind of visualize all of these things. I think AI is very good at summarizing and distilling that information. So you get the result from a tool that we've used before we had Gen AI, but then Gen AI can actually summarize those, make it available in a report, push it downstream if we're talking kind of being more agentic, working with other agents. So I think we can automate a lot of the, I would say, just cold storage problem and like what we had to do as humans anyways in communication and interfacing and a lot of those things.
Right. Yeah. We just touched upon something earlier. You talked about, the benchmarks, 4.5. People are obviously, there are flashy demos and there are people questioning those demos. And then there are people, who love those benchmarks, and there are people who don't want to question those benchmarks. But when you really scratch the surface, we're really looking at what's the real substance here. And it has come to me, at least, that sometimes AI models are either over trusted or they are under trusted. And do you think that's the case too?
Yes. So sometimes I think it depends on the situation. So often, yes. So especially by those who see the polished language and not kind of the limitations under the hood. But if you're aware of them, I think it's different. I think at the same time, the models are also understood, if that makes sense. I think many users, even executives, they don't grasp that LLM has no intent or true knowledge. It doesn't have a way of verifying facts easily. It generates predictable text. They also may not understand concepts like training data bias, of course, context window limits, like the reasoning that we also discussed earlier. So I think this lack of understanding means that people might use AI inappropriately. But I think on the flip side, some experts would say that models are undertrusted in the sense that with proper precautions, they can be extremely useful. But yeah, so it's kind of, I'm always on the air of caution and informed usage rather than blind trust. So yeah, they tend to be over-trusted precisely because their functioning is understood.
Got it. And one of the things that's been happening, is in the last 6 months, I think it's almost like a business mandate that you have to have AI in your pitch and maybe in your business for that matter. And, I think almost every CEO or the board is signing off on $1 million paychecks, saying that we have to have AI. But don't you think there has to be some sort of a checklist while you're implementing or wanting to implement AI tools or evaluating them for that matter? And what should those questions look like?
Yeah, that's a great question, because everyone's talking about AI, right? I mean, it's also executives are being pressured kind of from the top, and it's also boards pressuring. It's also their investors pressuring. How are we going to stay competitive? Other things. So it's like this huge chain of events, and it is a true disruption. But I think when I talk to executives about AI, I often give them kind of a simple, I guess, checklist of sanity checks. So first, ask how the AI verifies its answers. Does it show sources, how it came to the conclusion, what types of data it used? Does it cross-check against the knowledge base? So if the answer is more of a black box, basically trust me, I think that's a red flag, and it exposes you to risk. So in our world, for example, we like AI that can refer back to a knowledge graph or a database, something that grounds its answers. So if I ask a question about our kind of business data, I want the AI to effectively say, here's my answer. And by the way, it's because of these data points and relationships, and this is how I connected the dots essentially to get to that answer. So, and the second thing is I think ask what happens when it's wrong. So that's important. So every AI gets things wrong. So a robust system should have a way to catch or handle errors. Maybe it flags low confidence, or maybe it hands off to a human. The worst thing is that is an AI that is wrong and is confidently wrong. That's the most dangerous thing. And if it happens without anyone knowing, then you're suddenly making decisions on data that doesn't make sense. I mean, look at the banks after the kind of the 2008 financial crisis. There's been lots of pressure from the regulators. You need to have data lineage. You need to understand, where did this number come from? Like, where did we compute it? What sources did we use? Where did those sources come from? How do we get to those projections and those numbers? And those are being kind of often stress tested, and we have a very good framework for handling, I guess, financial stresses and other things, because we've been burned before. So I think it's the same is going to be kind of for AI here. So an executive should insist on understanding what are the failure modes. So if the vendor can explain how the system fails and recovers, then be wary. And the third, can the AI reason, or is it just responding? It goes back to what we've been talking about before. Is it doing more than parroting information? Can it solve multi-step problems, explain the solution? So for instance, if you give it kind of a curveball question, does it break down logically, or does it just fumble and give you a nonsensical answer? So I encourage leaders to actually test AI demos with questions that require reasoning or combining facts. So see if AI can connect the dots in a way that makes sense. So in short, the checklist is verification, fail-safes, and reasoning. So if an AI tool can show you it has those three aspects covered, it can back up its outputs, it has a plan for mistakes, and it demonstrates real reasoning ability, then you're less likely to be kind of misled by something that merely sounds intelligent.
Got it. And do you think if you were to redesign AI, would you change anything, or you're fine the way it's come along so far?
No, I think it's a tremendous achievement. I mean, it's easy to say if we have a magic wand, we would fix all of these things with AI. But I think it's just a natural progression kind of with technology, and they're amazing tools right now. We're every day we're finding new ways to kind of better harness them. It's definitely been a game changer kind of in the business and in technology.
I think the last 6 months, not only we've moved from just AI, now we moved to agentic AI, On the other part, Nvidia has been launching robots. I think some of the Chinese companies have also already launched robots which have integrated AI in them. Do you think we might be out of jobs soon?
I think for maybe some of the things, definitely it could be. I think it is always an interesting interesting topic of debate. It's going to offload probably a lot of the things that we are currently doing. I don't think the transition is going to be as, I think, sudden as people sometimes fear. I think as we're seeing, like, we're a couple of years in, and it's just more of the decision support. It's taking the cognitive load off of what we're doing. But over time, I think that's it will give people time to adapt and to focus on other skills and new skills, and there's going to be a path, I think, forward for people, and it's going to be a long time before we actually get to something that can completely replace us. Sometimes when the parrot sounds very convincing, you just need to remember it's a transformer architecture. It predicts the next word kind of based on what it has seen so far. So until we get a fundamental change in kind of architecture of AI, we've been relying on transformers for the last 10 years. So when we do that, so I think we're now getting to the productivity level where they are productive. Like the early ones haven't been kind of that exciting. But as we go further, I think it's going to be even more usefulness. People will get a lot more productivity. Companies will get done more things, bring more value, I guess, to everyone. I think everyone wins in that scenario.
Right. So what I'm hearing is, there's still time, and it's just going to be like back in the day when, computers were invented, and then we just kind of said we're all going to be out of jobs, but then we evolved, the jobs changed. We're doing different things now. OpenAI was able to source so much data to be able to train their models. And it has been, OpenAI for the longest time has been under the scanner, for using data without permissions. Do you think it's fair?
I don't think people should just use all the data kind of freely for sourcing. I think because a lot of those things, if they're hallucinated, especially if you're using like personal data that people are maybe putting in the prompts, for example, and let's say the AI, some model tends to be overfitted, and it really just recollects the things that it has seen, and sometimes it can come from like different leaks, and of course, if you're using someone else's data, I mean, look at what happened with Stack Overflow. Like the traffic has been down, and AI was trained on all of the expert knowledge that people kept put into those systems for years. And I don't think it's exactly fair. I think whoever are the producers of data, there's going to be producers of data, and I think they need to have certain benefit kind of even in this system. We need to find a way to get those things.
I'm just worried about my privacy, and what I put out there, and which AI system is going to pick it up, and what is it going to make of it.
Yes. I think that's the trend that's going to continue. So anyone who has a significant amount of data that was somewhat protected from getting scraped into AI, I think that is going to be what if people say data is the new oil? I think we're now getting to the point where people are really thinking about, oil prices are going up. I need to start acquiring companies that have that data as quickly as I can, so I can integrate that into my models and kind of get to the cutting edge. So I don't think we've seen the last of it.
To wrap up on a light, energetic note, we'd love for our audiences, to know you a little more personally, connect to you beyond being a CEO, and a competitive coder, as a human being. What's the one app that you can't live without?
Slack. Our team's distributed. We're moving fast. I think lots of things are happening on Slack. It became sort of a central nervous system for work. But yeah, I think for personal use, maybe Spotify. I listen to a lot of music. I think, but day to day, Slack, I think, keeps everything moving.
If you weren't building Memgraph, what career would you have chosen?
Oh, honestly, I think if I was back in the university days, probably I would say an engineer in some other field, maybe aerospace. I've
Oh,
been
nice.
always fascinating. I'm a barista as well.
What's that one quote or motto you live by?
Oh, that's a good one. So I think we actually live by it at Memgraph. So it's one of our values: build relationships, not edges. So it's a funny wordplay there, but it's kind of a fun play on graph terminology. But I take it to heart because it reminds me to focus on kind of people and the connections, not just the technical edges.
Books, podcast, or YouTube videos? What's your favorite way to learn?
I've always been what's the word, multimodal maybe learner. So even when I read books, I tend to prefer like audiobooks and then do something that's not taxing on the mind, like washing up dishes, stuff like that. But if I really need to learn something, I actually combine, which is maybe a weird thing to do, but I combine books and audiobooks.
Are you more of a sneakers kind of a guy or a flip-flops kind of a guy?
Sneakers, to be honest.
Nice. Which is one country you would love to visit if you haven't already visited it?
I haven't. I said I would like to see Iceland.
And the final one, if you were to teleport yourself to any point in time, past or future, where would you go?
Ooh. If I think if we could be future, I think I would probably do a near future and see how this whole AI thing plays out. I think if I go too far in the future, it's going to be very I wouldn't be able to understand it
Yeah.
because the world is going to change and I wouldn't be able to make kind of
Makes
guesses
sense.
on how it evolved, make sense of it.
Yeah.
So I think a shorter future, like 20 years from now, maybe. I think that would be an interesting. So we have kind of AI agents working on behalf of us. Did we manage to solve the climate problem and other things? I think that'd be interesting to see something in the short future. I think from the past, there's lots of interesting moments. I would love to see the moon landing, of course,
Oh,
and some of these kind of great maybe human achievements in the past.
nice.
I would have loved to have known people like Tesla and get a glimpse into their brain and how they operated kind of back in the day when they were alive. So I think those would be, I think, valuable moments. If I have to come back and bring those with me, I think those would be kind of valuable.
Personally, for me, it's the moment when Newton discovered gravity.
Oh, that's so good. That's so good.
Because I, for whatever reason, I would find it hilarious as well. Because it's.
But,
I mean, you've been the
sitting
apples have been
in the
falling
background,
for
just
so
looking
long.
at the tree. It's like, when is it gonna fall? Looking at the
Yeah.
apple, when is it gonna fall?
And I'd be like just staring at him. And apples have been falling for a really long time, bro.
Oh, awesome.
So thank you so much for joining us, Dominic, today. I really appreciate this. I had a great time chatting with you. And any parting words that you'd love to put forth?
Thank you for having me, and thank you for the very nice words. I hope it didn't come too nasally in my conversation. I've been sick for a week, but I had a great time. I'd love to be back.
Thanks for tuning in. If you enjoyed this episode, subscribe on YouTube, Instagram, or your favorite podcast app. Catch past episodes and more at techdogs.com. See you next time.